Hello everyone, welcome to Clashing Coder. So in this video we will see the question House Robber 2, which is in continuation of the question on which I made the video for the House Robber 1. So it is 213 question and it is a medium level question and will be more difficult than the House Robber 1, but it is easy if you know and you have solved House Robber 1. So I would recommend you to, before solving this video or watching this video and solving this question, you should watch the House Robber 1 video, so you will get idea of how to solve this. So let's see the problem statement. You are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. All houses at this place are arranged in circle. So here the difference is there with the House Robber 1. In House Robber 1 it was the same condition. All the houses have some money and we have to rob them and make the maximum profit. But now in this they are arranged in circular manner. In the previous one it was not in circular manner. So that means the first house is the neighbor of the last one. Meanwhile adjacent houses have the security system connected and it will automatically contact the police if two adjacent houses were broken into a same night. So that means that we cannot rob the adjacent houses. So it is similar to the problem number 1 or the House Robber 1. But in this you cannot loot the first and the last houses together because they are arranged in a circular manner. So that means the first one is connected to the last one. So if you loot first one, the this alert will go on, so the police will come. So that's why you cannot loot the first and the last index or the last house simultaneously. You have to take care of that. This is the added constraint in this problem rather than the first one. So let's see. Given a list of non-negative integers numbers representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. So this is if you have solved House Robber 1, so you will understand how to solve this actually, how you can approach this. So if you see in this example we are given 2, 3 and 2. So that means we cannot rob 1 and last index together. So either we rob this 2, we will end up having 2 profit, either we rob this 2 or either we rob this 3. So 3 will end up giving the maximum profit rather than this rather than robbing this 2, the starting index 2 or the last index 2. So that means the maximum profit will be 3. So I will if you can see if the number of house is 0 or 1 house, then you will simply return the profit of the 1 house. If the number is 0, you can simply return the empty array or empty empty int value. Otherwise if you have 2 values, that means you can return max of both. You cannot do both together because they are adjacent. So that's why you will, if you for example if you don't have this 2 here, so you have only 2 and 3, so out of both you will return the maximum value because you can root only 1 out of both. So that's why. So let's see how we can approach this question. If you have solved the previous question House Robber 1, you would be knowing the recursion approach. Actually if you see in at a single point, actually if you see in this question the 1 and the second index is connected, so you cannot root both of them. If in this example it is a second example, from here you can see, so in this example not second actually, so I don't know. So yeah, in this example if you see we are given 1, 2, 3, 4, 2. If you try to gain the maximum profit, so if you like run check from here, let's see. So if you loot this 1, so you cannot loot this 2. If you loot 1, then you can loot this 3. So the total will be actually 4. But you cannot loot this 2 because they are connected actually. So that's why you will end up having profit of 1 and 3. So if you see, you can add this 2, so it will become 6. But that is not where our profit is coming. Actually our profit is coming from this part. That is if we loot this 2 actually and this 4. If we loot this 2 and this 4, then only we will be getting a profit of 6. So that means that the maximum profit is coming from these 2 indices. If you try to loot this 3 and this 2, if you don't loot this 1, so that means you can skip this 2 also. You can loot, if you loot this 2, then that means you will have to skip 1. So if you try to add this 3 plus 2, it will be 5. So it will be still less than the maximum profit that we are getting through this 2 and 4, that will be 6. So that is the basic problem that we are given. So if you see, now we have a constraint, we cannot root them together. In a recursive approach, I would recommend you to watch the first video also. I will provide the link in the description and also in the info button. So let's see. So at every point you have a choice to make. Actually every point you have 2 choices to make. Either you include this particular house or rob this particular house, or you don't rob this house. If you rob this house, then you cannot drop the next house. So if you drop this house, for example, if you have dropped this house, so it will be plus. If you have not dropped, so it will be -1. So if you drop this house, our I is at this index, so the next I will be, or starting index of array will not be the I+1 index, because we have dropped the first house, so we cannot drop the second or the adjacent house. So it will be passed as I+2, which will be 3. So here our I will be passed as I+2. So if you see, now if we include this, we will actually have to now if we have been given this array, next we will get 3, 4 and 2. Out of, again they will be recursively calling. If we load this 3, we cannot load this 4, and now we cannot load this 2 also. So we will see how we can do it in efficient approach actually. But in this recursive approach, I hope you got the point actually. How, if we have two choices to make, either we loot the house or we don't loot the house. If we don't drop this house, so that means we will not drop any house, so we will not have any profit. Here our profit was also coming. So actually, out of both condition, if we rob the house and if we don't rob the house, we will take the maximum of both actually. If we rob the house, okay, not robbed and robbed, so it will be a maximum of both that we will be returning in our recursive function. So it is a recursive approach, so it will take a lot of time, and we will end up like calculating the same like value for same sub problem again and again. So rather than doing that, we can use a memorization, or we can optimally use a DP. So let's see how we can do that. So I hope you got the recursive approach, and do remember that at every point we have two choices to make. Either we include the item or we don't include the item. So let's see in the, this problem. So actually for this sake, for this example sake, so you should forget that we have any condition for the circular part. So I will explain you how we can solve the house robber 1. Actually, how we solve the house robber 1, it will be actually summary of that. So if you see, we make our DP array for solving the house robber 1. We used to make our DP array. So for example, this is our DP array. So we will initialize the first index as this same 1. So first index will be same, because you don't have any choice. You I loot this, so the maximum profit that you will be getting is 1 only. If you loot this, if you don't loot this, so you will get the maximum profit by looting this. So at second point, at the second index, I told you if there are only two values that are given, 1 and 2, for example, two houses, so out of both you cannot drop together, so you will drop the maximum of both, which will be 2. So you will drop 2, so maximum will be 2 out of this 1 and 2. Now at this point, when you come at this point, you cannot include the profit of this, so you will include the profit of dp of I minus 2. If you see, you can include the profit of only dp of I minus 2, which will be 1, and the current value, that is 3. So 1 plus 3 will be 4. So 4 is greater than this 2. You will have to choose from the maximum of, actually let me write it, maximum of dp of I minus 2. I minus 2 will be this index, actually this one. If we are filling for this, if we are filling for this index, so it will dp of I minus 2 will be this point, and dp of I minus 2, that means we are not including the previous house, we are including the previous to previous house. So we will include the current house, so which is the profit for that will be array of I, and out of that max, this is the one value, and other value will be simply the previous value, that will be dp of I minus 1. This is what we were doing in the first solution, which was house robber 1, which was for house robber 1. So at this point, if you see, 1 plus 4 will be 1 plus 3 will be 4, so it will be greater than this 2, so we will end up having 4 value. Now at this point we will choose the max of this 4, or 4 plus 2. 4 plus 2 will be 6, so it will be greater than this 4, so we will simply choose 6 here. And if we are like thinking it is a house robber 1 problem, so we don't have any constraint for the circular part. So if you see at this point 2, so 2 plus 2 plus 4 will be 6, so it will be maximum actually 6 and 6, max of both will be 6 only, so it will be coming 6 only. But now as we are given that we only have if we can only do the first house or the last house, but we cannot do both together. So for doing that, for example, you can think of this as connected. So for doing that, we will simply use the algorithm that I told you for the first problem that we used for this problem. We can simply do that by making two arrays out of this array, because if you see, if we include this one, so we cannot include this 2, so we can simply remove it from the array. So we will like make a array dp1, you can say dp1 array, which will include the values as, let me write it, so which will include values as 1, 1, 2, 3 and 4. So we will simply take this last index out of this array. If we simply take this out, so now we can run the function that I have told you, that the algorithm 1, that we used for the house robber 1 and on this array, and we will end up having maximum profit that we can get. So it will be 6 only. If you see, 2 plus 4 will be 6 and 1 plus 3 will be 4, so 6 will be greater, so we'll be end up having 6 profit. So if we and for second array, what we will do is, for the second array we will not include the first element and we will include the last element. For doing that, we can simply return I plus 1 index, so it will be 2 3, okay, 2 3 and 4 and 2. So now for this also we will calculate the maximum profit. So if you see, in this also our 2 and 4 is coming, so it will be maximum will be 6, and for, here if you check 3 plus 2, it will be 5, so again 6 is greater. So our output will be max of the both arrays profit that we are getting. So let's see, I have written the pseudocode also, you can see. So this is the pseudocode. Actually this code is similar to the house robber 1, or actually same code I have copied from the house robber 1, and this is what we have to do. Actually, if you see, we are given this array, okay, we are given this array. So now we cannot loop 1 and 2 together. They are connected, okay, they are connected. We cannot loop together. So what we will do is, we will simply make 2 arrays out of this one array. So we will make dp of 1. So dp of 1, you can see I have written dp of 1 array, and from this first array, in first array, we will not include the last item. Actually, we will not include the last item. So actually, this is a pseudocode. I will show you the code in Python in this time, and in next video I will show you the code in C++ for another problem. So you can see 1 2. So we will have 1 comma 2 comma 3 comma 4. So we will get the dp of 1 as this. We will include the first element and we will not include the second element, as they are circularly connected or connected in circular manner, so we cannot loop together. So that's why we'll create this array. Next array will be dp of 2, which will be equal to, we will not include the first element in this. So it will have 2 3 4 and 2. Now you can see we have got our dp arrays. Now as we have made the function for the house robber 1, we will simply use that function and pass the dp instead of passing the total the original array, we will pass this dp1 array and dp2 array, and we will get the maximum profit out of both. This is what we were doing actually, if you remember. This is what I told you in this example also. This is you can see, for we will initialize the first index will be same. So in this I will not use or make a different dp array. If I'm given this array, so let me actually erase this thing. So let me change this also. So in this array, if you see, in this array we will be passing d1. First we will passing d1. So if we pass d1, so we will be getting this. So I will, instead of creating dp array 2, I will use the original array, that is dp this. I will the past array that we have, I will use this only to make or get the result. So let's see. So first, our first index is initialized as it is because we are using the original array only. So now for the second index, it will be the maximum of the first and the second, as I told you. So it will be 2 only. Maximum will be out of 1 and 2 will be 2 only. So we'll have 2 only. You can see we are initializing this array. So now we will start from the second index, and starting from the second index, we will check if we add this 1 and 3. So this is actually our original array also and dp array also. We will save our space if you use this technique. So if we add this 1 and 3, so profit will be 5 if you see. So at this point, I is at this point. So it will be dp of I. This dp of I, which is 3, will be we will set its value as maximum of dp of I minus 1, which will be 2. So maximum of it is 2. So okay, I will write here 2, and another value is the dp of I minus 2, which will be 1 plus 3. That is the current value that we are having at this index. So we can loop 1 and 2 because they are not adjacent and we are leaving 2. If for example, if we had like 5 here, so 5 will be greater than this 1 plus 3, that will be 4. So that means we don't loop this 1 and 3, we simply loop this 2, we can add that. So now at this point our value will become as 4. So we will update it as 4. So now again coming to the next index, so I will come here. So now our I is at here. So now again we will check 4. So let me erase this mess. So 3, yeah. So we erase this. So our I is at this point. So we will check 4 plus 2. It will be 6. So either 6 is greater than 3. So 4 we were having here. So 4. So yes, 6 is greater than 4. So that means at this point we will update is to 6. So at the last we will have the maximum profit that we can get at the ending index, as we are using a DPR. So it will be 6. So we will simply return 6 here. So for the second array also we will pass the same function. So it will be 2 plus 4 or 3 plus 2. So it will be 6 only. So maximum will be 6. And out of both, at the end we will have the value dp of, okay. So you can see we have calculated the max profit that we can get for dp of 1 and dp of 2. And at the end we will return the max of both. Actually, if you see, we will return the max of profit 1 and profit 2. profit 1 will be for the DPRA 1 and profit 2 will be for the DPRA 2. So we will end up solving our problem, that is house robber 1, with using the circular condition also, the circular constraint also. We have solved our problem. So let's see the code also. So I have shown the code in the Python, and also for the time complexity, actually if you see, we are only traversing this n time, so actually it will be 2n, so you can say it as n. It will be approximately n time complexity, and the space will be also n because we are 2 of n, or n you can say because we are using 2 DPRS, because you can see we are using the space, so that will end up having taking the space. So let's see the code. So I have written the code in Python this time. So let's see. So in this you can see, first of all we will check the for the base condition. So I've checked taken the length of this array into n. Now we will check if the array is empty, so we can simply return the 0, because if we don't have any house, so we will end up having 0 profit. If we have one house, we can simply return that house profit, because it has no adjacent house, so we can simply loot it. Either if we have two houses, so this is also base condition that we are initializing here. You can see we are initializing this condition here. If we have two houses, we can loot one of one of them, not together both. So we will root the maximum of both, so it will be numbers of 0 and numbers of 1. So you can see I have actually told you how to do that. So this will be our main function that will be calculating the max profit. But let's see, this will be the first step. So if you see this, first of all we are creating the DP excluding the last element. So as I told you, DP of 1 will be excluding the last element, which was here. The last element was actually, if you see in this example, last element will be 1. So we will be creating this 1 2 3 array into this, saving this into DP of excluding the last element. So you can see numbers of this is Python syntax. Okay, so then we will be calculating the profit for this element using this function which I have taught you. So it will be taking the length of the DP array, then we will initialize the first element, the first index. So it will be max of the 0th index and the first index. Then we will run the loop from second index till the nth value. Then we will check if the previous value is greater or the current value plus the previous to previous value is greater. So we will keep updating the profit accordingly, and then we will return the ending index. So in Python you can simply return the DP of -1. You will be knowing that. So you will end up returning the 6 here. So that will be the maximum profit for this DP array if we include the first and exclude the last element. For the second array, you will simply exclude this one and include this 2 3 1 1. You will pass that to the function again. You can see we are excluding the 0th index, we are passing from 1 to n. So then we will calculate the profit for the same, and we will return the maximum out of both profit. As I told you, we are returning the maximum of the both. For example, if we were given you can see, if we were given here 3, we were given 3. So at that time we will have value as not 3, actually 4. Then we will have value as 3 plus 4, that will be 7, which will be greater than 6. So in the first function we will return 6. In the second function our last value will be 7. So we will return the profit of 7. So our answer will change. It will be getting the 7 value. Answer will be 7. So let's see and submit this code. So I hope you like this video and do find it did find it helpful. So you can see it ran faster than 99.26% of solutions and took less memory than 99.97% of solution. And you can see this code is also in Python, so it will be running slower than C++. So you can simply convert it to C++ if you know C++. So actually I will share this code in description in the GitHub link. So let's hope so you find it helpful. Thank you for watching guys. Do like this video and subscribe the channel for watching. Thank you.